Alright, so I already have the standard solution of iron ferrous ammonium sulfate made up. I have a solution of 110 phenanthroline already prepared. However, we need to prepare our sodium acetate solution. That's going to be a buffer to maintain our pH within a range where the phenanthroline will actually be able to complex the iron. This can be prepared ahead of time. All three of these solutions should be stable over at least a couple of days. These two will be stable indefinitely. So you can prepare those a month in advance easily. This one should be prepared no more than a couple of days before the procedure you're wanting to use. The hydroxylamine solution, however, should be prepared the day of. So this is a fairly strong reducing agent, and that means that in the presence of air, oxygen in solution, it is eventually going to decompose. So we want to prepare this one the day of. All right, so the first thing is our sodium acetate solution. You want to prepare a solution that is 1.2 molar. Now, depending on the volume that you need for your lab, that's going to determine then the amount of sodium acetate you need. For me, I'm going to only need about 80 milliliters of solution. Let me just double check and make sure I prepare the right amount. So yes, so 80 milliliters of solution, so I'll need 7.87 grams, and approximate masses are sufficient. All right, so that will be 7.88 grams. That will be close enough. Just cap this and set it aside. And then again, approximate measurements are more than sufficient for this. So I'm just going to use the beaker, the markings on the beaker, to get about 80 milliliters of the solution. All right. So while we're waiting on that, go ahead and wipe my spoon off so I can reuse it. Just stir this briefly to get it to dissolve. So sodium acetate should dissolve pretty readily. However, it can take it a minute in order to get full dissolution of your salt. And this is where if you have access to a magnetic stir plate and a stir bar, this will make your life a lot easier, especially if you're prepping this in large volumes ahead of time. Go ahead and set that aside. Right, now for the hydroxylamine solution, we actually only need about 1 ml of this solution. You want to prepare it, let me double check and make sure I tell you correctly. Yes, we're going to have a goal of 1.4 molar. You'll only need at that concentration about 1 ml of solution per 100 milliliter volumetric flask. So even if you're using 20, if you're preparing 20 of these samples, then you'd only need a volume total of about 20 milliliters. In my case, I'm only going to prepare 10 milliliters of solution, and that's going to require basically 1 gram of hydroxylamine hydrochloride. All right, and we'll go ahead and use the small beaker for this. Okay. So this is a little bit hygroscopic, so it can be a little bit chunky as it comes out of the bottle. That's okay. Once again, we only need approximate concentrations for this. So it should be fine. If it's absorbed a little bit of water and the mass is a little bit off, that'll be okay. Now I do want to note that hydroxylamine hydrochloride is labeled as toxic for aquatic life, right? So we do not want to be putting these down the drain. Hydroxylamine, anything with the hydroxylamine in it should end up in an appropriate waste disposal container. The same thing goes for the 110 phenanthroline. However, the sulfuric acid we're working with is in low enough concentrations, as is the iron ferrous ammonium sulfate, and the sodium acetate is of course non-hazardous, so those solutions do not need any special disposal procedures. All right, and that is 1.04 grams. So once again, that is more than close enough. And again, we'll just add approximately 10 milliliters of water to that solution in order to get our hydroxylamine hydrochloride solution. There we go. Now that we have all of our solutions prepped, it's just a matter of dissolving all of those, and then we can begin our standard preparation process. All right, so at this point we can begin prepping our standard solutions. Now I want to emphasize at the front end of this that once we add everything to the standards and dilute them to volume, they do need to sit for at least 15 minutes to allow the color to fully develop. So the species that we're measuring is going to be iron tris phenanthroline. And we need to allow time for that complex to form. Now, once it forms, it should be stable for about 2 hours. With my own experiments, the absorbance will start to drop off after about 3 hours. So you've got about a 2-hour window once the standards have been prepared in order to actually perform your measurement and get good quality data. So this is our stock solution. As I said earlier, this is about 10 part per million iron. You want to calculate your own exactly. Go. Now you can pipette directly out of this. However, I personally find that to be difficult, and then you also risk contaminating your stock solution, particularly if your stock is going to be used across multiple groups of students. So I recommend pouring this into a beaker and then just rinsing the beaker several times with that stock solution. This just ensures that the concentration of what will be in the beaker is going to match exactly the concentration of what's going to be in your flask. All right. Go ahead and set that aside. Send it over here. Okay, so for our experiment, my goal is to turn this 10 part per million iron solution into a very varying levels of part per million concentrations of iron. So we're going to make 4 standards. We're going for roughly a 0.1 part per million. This will be then roughly 0.4, 0.7, and then 1 part per million iron. So these are going to be our concentrations of standards once we finish the whole procedure. Now to do this, I'm going to use my serialized pipette. The advantage of the serialized pipette is just that I can now deliver all of these using the same pipette instead of using different pipettes. That said, we need to rinse this with our standard solution before we begin. So just go ahead and fill the pipette. You want to fill it most of the way up, so well past the marks that you're going to be measuring to. And then allow it to drain into waste. And again, the rule of 3 applies here, so we'll go ahead and repeat that rinse 2 more times. So now that our pipette has been rinsed and we can be confident that we're not going to dilute our standard solution, I'm going to go ahead and start with the most dilute standard and then work my way up. So in order to get this to be about 0.1 part per million, I need to add 1 milliliter of this, and then I'll dilute up to volume of the 100 milliliter flask. We'll set these off to the side so they're not in the way. Now in this particular serialized pipette, it's labeled for 1 to 10 milliliters, starting from 9 going up to 0, so kind of like the labeling on a burette. So, pulling up past the desired volume, I'm going to allow it to drain back into my standard solution until I reach the 9 mark. And sometimes you have to kind of get down in order to accurately see where your meniscus is. Right. Here we go. And then just allow it to drain. Alright, so that's standard 1. It's a good idea to label these as you go, unless your memory is significantly better than mine. We'll go ahead and add the iron solution to all of our standards before we add the complexing reagents. Repeat this process. We'll need 4 mLs this time, so right on this model of pipette, I'm going to raise it up past 6 and allow it to drain down. And some pipettes do drain rather quickly, and if you find you're having trouble controlling the flow rate in order to actually get the desired volume, it helps to rest the bottom of the pipette on the bottom of your container that you're allowing it to drain back into. That will slow the flow down and allow you to more easily obtain a situation where the meniscus is sitting exactly on the line. Alright, so that is 2. Standard 3 is going to have 7 milliliters. And it is not necessary to use 4 standards. The minimum number of standards required for this procedure is 3 standards. However, the more standards you create, the more accurate your line is going to be for determining your unknown concentration. final standard, we're going to deliver 10 milliliters of our desired solution into our volumetric flask. So overall, we should have 4 standards ranging from 0.1 part per million in iron 2 to 1 part per million in iron 2. And if you recall from the beginning, that 1 part per million is the maximum concentration of iron in natural water recommended by the EPA in order to not result in damage to the aquatic life. So hopefully, our iron concentrations will be significantly less than the 1 part per million standard. All right. Now that we have added our iron standard to each of these, we need to add the remaining reagents that will actually allow us to develop color in these solutions. So in order to do that, we have our 1,10-phenanthrene, our hydroxylamine, and then our sodium acetate. We're going to add each of these. So for the 1,10-phenanthrene and the sodium acetate, each standard is going to get 10 milliliters, and then we'll need 1 milliliter of hydroxylamine for each of the standards. Now, at the same time that we're doing this, I'm going to go ahead and prepare a blank solution. Now, the blank does not necessarily have to be in a volumetric flask. We just want to ensure that we have approximately the same concentrations of everything except for our iron. So this will get 1 milliliter of hydroxylamine, this will get 10 milliliters of phenanthrene solution, and 10 milliliters of sodium acetate solution. And then we will hopefully have no color, because the rest of it will just be distilled water. All right, now for this measurement, a graduated cylinder is sufficient. You don't need to use volumetric pipettes. I would, however, recommend that you put gloves on for this, just because it's easy to spill while transferring these. And while the sodium acetate is not really going to hurt you, the other two are not necessarily, well, let's just say I wouldn't recommend them as moisturizers. So, our phenanthrene. You can see instantly we get an orange color developing. We're going to allow it to sit though for 15 minutes in order to get a full color development. 10 milliliters of our sodium acetate buffer solution. And then 1 milliliter of hydroxylamine. And again, it's not necessary to be completely precise on this. Didn't quite get it all. Okay. Now we need to dilute the volume, right? So a volumetric flask is calibrated to hold exactly the amount marked. So for this, which is a Class A 100 milliliters, this should hold 100.00 milliliters when diluted to the mark, plus or minus 0.0 some milliliters. And we won't necessarily dilute fully at this point. We just want to add some of the solution so we can allow the color to develop more easily before being fully diluted. Allow that to stand while we prep our other solutions. The exact order of addition here is not necessary. Not necessarily important. Again, 1 milliliter of hydroxylamine, 10 milliliters of sodium acetate, and 10 milliliters of phenanthrylene solution. And then go ahead and just do the initial dilution. All right. As we progress from one solution to the next, we should get a steady darkening of the color, right? Because we're adding more and more iron each time. So the only thing that should change between these standards is the amount of iron solution added. Everything else should be exactly the same. Bit excess in there. There we go. That is it for our 4 standard solutions. We'll have to finish diluting them to volume. However, once again, once we've done this addition, we have to allow these things at least 15 minutes for the color to fully develop. So from this point on, it's a good idea to just set your timer for 15 minutes, or note the time, or however you want to do it, and then wait until that is over in order to do your actual UV vis measurements. Patience is your friend at this step. Rushing this can result in issues, so you want to make sure that you wait 15 minutes for the color to develop. Now we can go ahead and complete our blank solution, right, which should have everything the same except for no iron will be added. And a little bit residual in there. So 1 milliliter of hydroxylamine solution, 10 mils of phenanthrylene, and then 10 mils of sodium acetate. And we'll dilute that to volume. Now, in theory, none of these should absorb very much in the same region that we're going to be looking. So in a pinch, it's okay to just use distilled water for your blank. However, this is going to give you a good idea of a very exact and standard way of preparing a blank solution.